So for a final talk for the day, we have again Anamika Roychowdhury from IBM, and the talk is on From JNI to the Future, the Evolution of Native Interoperability in Java. So this is the last talk for the day. We'll go a bit beyond, bit into the lunch hour, but I hope you all don't mind. Thank you.
Yeah, thank you. Yeah, so I don't know like how many of you have used like from Java code you have tried to contact the native code. And how many of you have used JNI Java native interface? Whoever have used, they have understand the pain of the like boilerplate code and all the conversion, marshalling of data and all. Yeah. So agenda of today is like what is beyond pure Java, why we actually need to go beyond pure Java. And then when you are trying to contact native from the Java, you need some kind of bridging, and there are different way of doing this bridging, and there is a evolution on this bridging part. And though there is an evolution, from the beginning of the Java, the most common technology for this is JNI, Java to Native Interface, and which have been used for many years. And but we will talk about the disadvantages of that JNI. We'll give one simple example so that you understand what we need to do with JNI. And then we talk about evolutionary feature that Java 21 has introduced called foreign function and memory API, and and we will talk about the different components that it has, so that it has addressed most of the disadvantages of JNI and how it is able to solve it. And we will take one example, and then we'll try to compare between JNI and using foreign function and memory API. Yeah. So what is native? I think most of you know, like which is not running inside the Java JVM. So, and it is mostly written in different programming language, mostly in C and C++. Okay, so why you need to go to native from Java? It's like Java is running on a wrapper on JVM, so it does not have direct contact to the operating system features. If you want to do a system call, in that case you have to go to native. So some of the platform performance critical operations run well in native, like real-time processing. Like I have talked about caching, which needs low latency. So you know, like in our product, like when you store the data on heap, the performance for a huge when you need lot of throughput, it's not that better. And if you actually store the data in the off-heap memory, like native memory, then the performance is better. So Java code is written in Java, but you still need to go to native to store the data for the better performance. Okay, and then some of the native libraries which is already available, like which is already doing very good, like for machine learning, TensorFlow. Then for CUDA, it is well known, it is native. So yeah, Java has to, and then real-time processing, graphics processing, Java has to talk to native, and there is no point, it is not practical to rewrite those in Java. So yeah, and then so some like sensor, some USB, those low level, so those hardware, Java alone cannot control it. Native only enables to do it. And then when you have like legacy software, it is already written in C, C++ code, and you are integrating it, in that case also you need to talk to native. Yeah, so and as I said that there must be some way of communicating from Java to the native, and this is called Java to native bridging. There are multiple ways of doing it. First is byte buffer area, like byte buffer API. Byte buffer API is available in Java. With that API, you can create a memory, byte buffer memory in the off-heap area, and then you can directly use it. But the disadvantages of it is that it is only a specific, it is only can be 2 GB, maximum of 2 GB. And there is lot of, if you are not using it very carefully, you can get out of memory leak, and then it will go to out of memory error. Yeah, so I myself have worked last week, has worked on a customer case where actually it was a memory leak and out of memory error, and it was byte buffer was leaking. Okay, and yeah, so and then unsafe API, as it has lot of capability, but the problem is it is unsafe, already told. Okay, so it can do all like whatever JVM is trying to do in a safer way, it does not do it in that way, and actually it can crash your JVM. Okay, and then JNI, Java to Native Interface, which is very popular and it's been used for multiple years. And there are like something called JNA, JNR, which has been like some initiative to improve the performance and efficiency of JNI, but it is still not that mature and has not got that popular. So, and then the evolutionary feature that I talked about, Java 21, it has actually started with, and then it has been completed in 22, foreign function and memory API. Okay, so the disadvantages of JNI, it is complexity and boilerplate code. So you need to write code in Java and C both. So you need to know both Java and C programming, and there is lot of JNI bridging code. So it is complex. And then for the C code, what you have written, okay, so that is not portable. So you have to build it in a different way for different platforms. So now Java is portable, but JNI is not. So write once and then run everywhere does not, fails here. Okay, then there is performance, though actually native does it, performance is better in the native, but the bridging between Java and native, there is a lot of performance over it sometimes. And then the memory management risks. Java programmers who are very much like used to with Java environment, with GC is doing all this memory management, and when you are writing a C code, it is very likely that you will write some bug. There'll be some bug in the code. There'll be free after use after free, buffer overflow, memory leak, dangling pointer. All this problem comes into picture. And then security concern. Yeah, if there is a memory leak, there will be security concern. And then type safe, like the lot of data marshalling between. So the Java memory layout and C native memory layout is very different. So when through JNI, you have to convert it from Java object to the C structure and C structure to the Java object. So there is, and in this way, there is a lot of possibility, then you will not typecast it properly, and then there is a memory, there is a security risk. Then hardware maintenance and testing, like I said, like you cannot for the native part of the code you have written, you have to build it properly. For testing it also, you need a different environment, so debugging is difficult here. And because of all this, it increases the development time. Okay, so yeah, so now look at, like, let's say I just want to call get PID, okay, from Java, and what are the different steps with JNI? So first, like, this is the Java code, which will actually, this native written public native int get PID, that is the method which will be actually doing the job, and this method has to be implemented in C. So, and you have to load the library that everybody was talking about, that .so library. So you have to load the library where this method is compiled in the C code. Okay. So, and then, so after you have written the Java code, you have to run java -h getpid.java to get the header files. And in the header files, there is lot of information. I have not given the header files here. Lot of information is there, and then there is a function structure and signature, everything that you have to do in the native, like C file. So this header file, we generate a method signature like that, and this method actually you have to implement in the C code. After you implement that in the C code, then you have to compile it, that he was talking about minus f peak. I don't want to talk about it. Yeah. So and then you do the GCC compiler, you just create the .so file. So this example is for Linux, and then for Windows you have a different command, and for other platform you have a different command. So you have different .so file for different platform, and yeah, and then you have to run the program. So when you run the program, there is something called java.library.path, which is a system property, and that path should be pointing to the path where this native .so file is located. Yeah, so there are so many steps involved when you actually doing it through JNI, and then later on we will write the same code with foreign function and memory API, and we see how easy it is. Yeah. So now let's move to so as I said that there are all the problems that we have discussed in JNI. Foreign function and memory API have tried to address this, but how? It has some components. If I don't discuss those components, it will not be clear that how it is able to do it. The first thing is the arena. So arena is kind of like responsible for managing the life cycle of the native memory segment. Okay, so you can flexibly create and free the memory segment. Okay, so there are 4 types of arena, like global arena, whose lifetime is bounded, and it cannot expire, it never expires. And then here is automatic arena. Arena lifetime is global arena lifetime is unbounded, it never expires. And then automatic arena lifetime is bounded, and it is actually managed by GC. So when all the memory segments in that arena is unreachable, it will be deleted by GC. It will be garbage collected. And then confined arena also lifetime is bounded, but it is only accessible by the single thread who has created it. And then shared arena. Shared arena is actually lifetime is bounded, and it is accessible by the multiple threads. Okay. So now there is something called memory segment. So memory segment is contiguous region of memory. This can be either off-if or on-if. So it actually solves 2 very popular common program error, like buffer overflow and use after free. So through 2 concepts called spatial boundary and temporal boundary. So through spatial boundary, it actually has allocated 200 bytes, and lower bound is 0, upper bound is 200. And now it is trying to access in the a memory which is outside the like in 201 offset, and it gets under exception out of bound. So yeah. So now there is no way of generating, even if you write a wrong code, no way of generating buffer overflow. And then use after free, like this arena has the life inside this try block only. And when you are trying to access that memory segment outside this memory try block, then you get exception. So it takes care of, after free you cannot use it. Okay. Then memory layout. So it acts like a blueprint for how to interpret raw data in a memory segment. So you can think of this as a Java equivalent C, like C structure, how we define. So like yeah. So then you have something called var layout, sequence layout. Var layout is for primitive types, then sequence layout for this guy is the array of elements, and then structural layout, it's same as C structure. Okay. And then you have something called var handle. Var handle is actually short form of variable handles. It's kind of a pointer which can have access the different variable defines inside a memory layout. Okay. So now let's take an example, like how we actually with this concepts arena, memory layout, memory segment, and then var layout, how we can actually access a C structure live definition in Java. So let's see structure is like that person who has int and height, and then we actually the same structure kind of a definition, equivalent definition is in Java, memory layout, person layout with this var layout, int age and then height, and then now we are trying to allocate a memory. It is a memory segment which will allocate. Arena inside the arena will take care of the lifetime and the restricted area to this memory segment. With the arena, I have allocated this memory segment of the kind of a person layout, and then with the var handle, I have got a different var handle, and I can actually access different object in read or set the value of different variable in that structure. Okay. So now it is very type safe, right, with the var handle. There is no like type safety that issue that we have discussed is here. Okay, now another, so this talks about how we actually access the memory, and then it talks now how we actually calls the functions that are defined in the native area. So first thing is function descriptor. You have to describe the native function with its signature. First one is the return type, and then all the arguments it takes. So this is the int add, int a and b. This is the similar the function that has been defined in the native C or C++ code, and then equivalent function descriptor for that is this, and then you have a linker. Okay, so you have to linker gets it provides access to the foreign function from the Java code via down call. There is something called down call and up call here, and then access to Java code from the foreign function through up call. And then there is something called symbol lookup, which actually look up the address of the symbol in one or more libraries, those DESO library, and symbols are actually the name of the function on the global variable. And we have something called method handler. Method handler actually binds that function symbol that has been found out. So you can method handler you can think of as a function pointer in the Java. So that in the Java function pointer is pointing to that function pointer which has been found in the native. So yeah. So now you can see that I want to use a function which is defined in the native, and which actually return type is int and takes two int parameter. So I have defined the function descriptor, and then with the linker I get the native linker, and with the symbol lookup I look up at this .so file and look up for this method name, and then I do a down call, and down call actually retrieves me the function pointer, and I save that function pointer in the method handler, and with the function pointer I can directly call the function. So you can see that you don't need to write any code in the C now, everything in Java side. So the same get PID that thing that we have written with JNI, now let's see how it will be in for FFM. Now see, that's the method signature, and this is the all Java code. There is only one step. So you just have to get the native linker with the symbol lookup. You get the lookup at the .so file. You find the function name, and function name all else throw. If you don't find it, then throw it error, and you just define the descriptor, and with the method handler you do a down call, get the pointer and bind the pointer to the Java and just call it. That's all. Yeah. Yeah, so now you already understood. Yeah.
Those linker steps which are there, you don't need to do any of that. The ones which were there in the JNI.
No, because you are not writing any code in the C. No.
Okay, got it.
So yeah. So and then benefits of that FFM area that we have already understood. It is very simplicity, type safety, better performance, memory safety, and you also that there is something called this part of code also. If you feel it is difficult to write, there is something called JExtract tool, okay, which is completely in Java, and you can take the help of that to write it. So yeah, it is, I think, a very, very powerful feature, and it is a new era which is giving to the Java developer who wants to talk to the native code from Java. Yeah, thank you.
Any questions?
Huh? So one of the question is that memory arena that you're allocating.
Memory segments are actually arena.
Yeah,
Arena is an amount of memory you can take.
Yeah.
It is a reserve to allocate a memory segment.
So you have a segment in which you've allocate, like you've given 200 bytes to the segment, and then you're creating a C style struct in that memory segment,
Yes.
and then passing it as a pointer to the C call.
Using var handle, yes.
Okay, so that memory segment follows the C style of struct
Yes.
definitions.
Yeah,
So
it
you
can
can.
actually have a like that is off if one. It can have a like Java like memory content also.
But C won't understand that.
No, C won't understand. But
You
but
can
it is
call
all
it.
in Java. I have given example for talking to C.
Okay.
That's why it is like that.
Okay, you can define in the same segment. You
Yeah,
can define
define
G,
Java
G
types,
and
yeah.
call dynamically call a Java jar. Okay, very well.
Hey, nice talk. First thing, if I am understanding correctly, this actually aids working from Java side to the native programs. But what about the other side? Like JNI always has two parts. You can
Yes.
also work from native
like
side.
yeah,
Huh.
that like I have told no down call. It is doing a down call. Then
Huh.
I let's say some structure is defined in the C, and there is a method defined in that C code to get the structure or set the structure. Okay, so from Java side you want to actually set the structure, so you will do the down call, and then from Java then you want to get the structure. In that case you have to do the up call.
Oh, actually, I meant something else.
Okay.
What I'm saying is basically when you call JNI APIs from native, like that's a different interface on that side. So, like, does FFM even touch that, or is it just for improving Java ergonomics of working with native side? Like
No,
that.
what JNI is able to do, say it is able to do the same. So JNI also is trying to, JNI is the bridge, is the from the objective is same. The same, like you want to talk to like get a let's say set or get a structure which is defined in the C. Okay, for JNI, the you do you need to write a code which is actually getting the structure and setting it in the C also. Okay, and then you have some part of code in the Java also. But in this case there is nothing in the native part. There is no JNI, those method signature, big method signature like underscore JNI call and all. It's not there. You just doing everything in the Java side, but you are still able to set the structure and get the structure. Okay, maybe I have.
Can go other way.
Yeah, so it definitely possible to go other
Okay,
way.
C wants to talk to Java.
Java.
Okay, yeah.
So the JVM APIs.
No, JNI is not for that.
You can do it.
It's not for that.
Completely for Java to call.
Yeah, Java to native interface.
Yes, that's
Okay. Okay. Cool. Yeah. No worries. We can
Yeah,
continue with that.
yeah.
So generally speaking, one of the best practices with JNI, the way it was, is that like you try to minimize the number of cross interface calls
Yes,
because
yes.
each interface call
Because
adds
a
like a
lot of
significant
overhead.
amount of overhead, right? Like, is that the same thing with FFM as well? Is generally the best practice to minimize the number of calls that you try to make?
No, because see, you are not writing all this bridging call.
Right.
Right, so you are bringing everything in the Java side, Java way of managing it.
Got it. So you're saying that, like, let's say for example, you have like a C API which performs a very short running operation, and you're calling that like a lot of times in the Java code.
Yes.
That is going to have better performance in
Yes.
FFM as compared
Yes.
to over JNI. Okay, got it. Thanks.
Last question.
To add on, okay,
Yeah.
to add on to his question a little bit. So, you using the JVM API, you can basically embed a JVM in a native program, like start one, and then call methods in it, like through the JNI API. But using FFM, you need a method handle created in Java for native code to be able to call Java methods, right? So does this mean that it'll only be useful for like callback type situations? Like you can't just give it a class and like tell the native code to call it. Sorry, I feel like I was unclear. Okay, so you using the JVM API.
Did anyone understand his question?
Okay,
It's
I should
little
explain. Yeah.
confusing for me.
So using a JVM, like the JVM API, you can embed a JVM in a native program.
Using a JVM API?
You can embed a JVM in a native program, like start
okay.
one using like the.
No, I am not embedding JVM in a native program.
But-
native is completely
Right, but you can do this.
No,
right?
JNI. Okay, JNI. The kind of a method using JNI I am writing in the native. It is completely native only. It does not understand anything about JVM, but there is something called JNI environment which get passed to that, and through that environment point structure I can get lot of information from Java. But it is still doing the same way of native is doing it. It is
I'm so
not
sorry,
doing
but
anything.
Let me
Yeah,
rephrase.
yeah.
So like
Okay. Yeah.
using JNI, you can call a method just using its descriptor. But with FFM, you can only call it when you have its method handle already given to you. So does that mean that you can only use FFM for upcalls when it's in like a callback type situation?
No, you can do a down call also. Means you want to fetch something from the C, that also you can do. Like I have given there a down call, no? So you have to do a up call there.
Right.
Okay. Okay, maybe.
So you started with the example of buffer overflow. So you
Byte buffer API.
Byte buffer overflow.
Byte buffer API.
But so you created a segment. What if I pass the pointer of that segment to C and then I try to overwrite it?
No, byte buffer. Actually, there is two types of byte buffer, like direct and non-direct. Like if byte buffer API can create a byte buffer inside heap, and also create byte buffer in the off if memory. And from the Java you can directly call it. Like Java do NIO call, right? Not network call. Network call has to talk to the native area. So through how it talks through that byte buffer API. Means byte buffer can create that memory, and then from Java can actually access that memory.
What I'm trying to ask is, one of the things is security, like type safety. Type safety is, I can see type safety. About memory safety, I allocated a segment, I passed the pointer to C. And if C overwrites or exceeds the bounds of that segment, that will still happen in this case, right? Nothing can prevent that.
Yes.
So you are trusting the C program to behave in a non-malicious way.
Yes.
That is still there. Just checking that part, since you mentioned byte buffer.
Okay, so that concludes the proceedings. We have one final announcement to make. Me and Pradeep, like if you enjoyed today's session, we host a compiler conference of our own. It's solely focused on compilers, and it's next weekend at IISc. So if you're interested in that, go to compilertech.org or reach out and talk to me and Pradeep.
It's so difficult to get seats. Like whenever the form comes up, like in 5 minutes, all the seats are full. I have tried with a couple of.
I mean, now it should be available. You can go try.
This is a compiler workshop that we are
Couple of questions. How often is this?
It's called the meetup.
And is it always at IISc?
No, so we hold meetups very regularly, like once a month or once every couple of months. The conference is once a year, but it's solely focused on compilers. Yeah, that's it.
Where are your meetups usually?
There are various places, sometimes at AMD office, sometimes at NVIDIA office, sometimes at IISc. We rotate.
IISc is like the other planet.
Yeah.
But you can still access the net.